Hello, in this lecture we will find the size of 2 times AP. Okay, we will find the size of 2 times AP, and actually we have here a triangle ABC that side AC equals to 70 units, side BC equals to 50 units, and the side AB of triangle ABC equals to 90 units. We also have here circle that the center of the circle is in point P, and point P is on side AB of the triangle, and actually side AC tangents the circle in point, the touching point, we will call it D, and side BC tangents the circle in point that we will call that point E. So the touching point is point E of side BC tangents the circle in point E, and the side AC of the circle tangents the circle in point D. Okay, so first of all we will connect by line points P and C. Okay, point P and C are connected. We also connect points P and D. So actually PD is the radius of the circle. Okay, because it is a line that starts from the center of the circle and touches the circle. So it is the radius of the circle. We will mark it as R, and also we will connect points P and E, and actually points P and D are also the radius of the circle. Okay, so actually we have a rule that says that if you have a circle and you have also external point of the circle, that is to say a point that is not in the circle or inside the circle or on the circle, but it is outside the circle. It is external point. Let's call it V. So if you have a circle and external point of circle, and you actually drew two tangents to the circle, this is one tangent, and this is the second tangent. Let's call the tangents point here as L, and tangents point of this line on the circle as F. So the rule says that the tangents are equals to each other. That is to say, VL equals to VF. Okay, VL equals to VF. So if you have a circle and from external point of that circle you drew two tangents to the circle, then those two tangents are equal to each other. So VL equals to VF. So according to this rule, we can say that in our specific drawing we have external point C that is outside the circle, and from that point we drew two tangents to the circle. So we have the first tangent that is CD and the second tangent that is CE. So according to the rule that I told you, CD must equals to CF, so to CE. CD equals to CE. Okay, the tangents that actually drawn to the circle, tangent CD equals to tangent CE. According to our rule, that whenever you draw two tangents from external point to the circle, those tangents are equal to each other. So CD equal to CE, and also DP equals to PE equals to R, because PD is the radius of the circle and PE is also the radius of the circle, so they are equal to each other. And of course, PC equals to itself. PC equals to PC. PC equals to PC. So actually, triangles PCE and triangle PDC congruent to each other. Okay, or triangle PCE overlap to triangle PDC. Okay, so we actually found out that EC CD equals to EC according to the rule that if you draw two tangents to a circle from external point of the circle, then those tangents are equal to each other. So C is external point of the circle, and from point C we drew actually two tangents to the circle, tangent CD and tangent CE. So according to our rule, they are equal to each other. So CD equals to CE, and also PD equals to PE equals to R. So PD is a radius of the circle, and PE is the radius of the same circle, so they're equal to each other. And of course, PC equals to itself. So we have here two triangles, triangle PCE and the triangle PDC, that actually three sides of triangle PDC equals to three sides of triangle PEC, because DC in this triangle equals to CE in this triangle. PD in this triangle equals to PE in this triangle, and PC equals to PC. So actually three sides of triangle CDP equals to three sides of triangle CEP. So therefore they are congruent to each other, or those two triangles equals to each other according to the rule that if you have two triangles and in one triangle all of its three sides equals to the three sides of the other triangles, then they are congruent to each other. They overlap each other. For this reason, triangle PDC congruent to triangle PEC, or triangle PDC overlap triangle CEP. Okay, so I can also show you the triangles. This triangle actually congruent this triangle. Okay, or triangle CDP overlapped triangle CEP. Okay, and for that reason angle PCD equals to angle CEP according to the rule that corresponding angles in congruent triangles are equal to each other. So triangle CDP congruent to triangle CEP, and for that reason angle CPCD equals to angle PCE. This angle equals to this angle. Again, angle PCD equals to angle PCE according to the rule that corresponding angles in congruent triangles are equal to each other. Okay? So now I will draw again triangle ABC. Or first of all, let's call triangle PCD theta. Okay? Triangle PCD will be called theta. So triangle PCE will be also theta because they are equal to each other. Okay? So this angle equals to this angle, or angle PCD equals to angle PCE. Okay? So now let's draw triangle ABC again. So this is triangle ABC, and actually according to bisector, angle bisector theorem, the bisector angle in a triangle divides the side that it hits in a ratio that equals to the ratio of the angles sides. So as you can see here, we have triangle ABC, and in triangle ABC we have bisector angle, because PC is bisector angle because it actually divides angle ACB to two equal parts, because this angle is theta and this angle is also equals to theta. So PC is actually bisector angle because it divides angle ACB in the triangle to two equal parts, because it actually creates angle theta that equals to angle theta. So this bisector divides the side that it eats, PC, the bisector angle, eats side AB in point P, and the theorem says that it divides side AB in a ratio that equals to the ratio of the angles sides. So actually the ratio of angles sides is AC over BC, and the angle bisector theorem states that the angle bisector CP divides the side that it eats in a ratio that equals to the ratio of the angles sides. The ratio of the angle is AC divided by BC. So the sentence claims that the angle bisector divides side AB in the same ratio. So AP divided over BP equals to the ratio of the angles sides. Angle ACB has two sides. Angle ACB has side AC and has side BC. So the ratio of those two sides are AC over BC. And the claim is that the angle bisector divides side AB in the same ratio of the angles sides. So that is to say AP over BP equals to AC over BC. Okay? Again, the angle bisector theorem says that actually the angle bisector, that is to say PC, divides the side that it eats. Angle CP eats side AB, and it divides side AB in a ratio, that is to say AP divided by BP equals to the same ratio of the angles sides. The ratio of the angle sides is AC over BC. So the ratio of the angle that is divided to two equal parts is AC over BC. And the sentence claims that the angle bisector divides side AB in the same ratio. So AC over BC will be equal to the AP over BP. Okay? I will return again. The angle bisector in triangle ABC is CP. Why? Because CP divides angle ACB to two equal parts. So this angle bisector actually divides angle AB that it hits on angle AB in triangle ABC. It hits in point P at angle AB, and the claim is that it divides sides AB in the same ratio of the angle ACB itself, or in the same ratio of the sides of the angle that it divides. So the sides of the angle that it divide to two equal parts is actually side AC and side BC. So the ratio AC over BC will be equal to the ratio of AP over BP, because it divides, the angle bisector divides the side that it hits in the same ratio of the angle that it divides to two equal parts. So the ratio between the angles sides, that is to say AC over BC, will be equal to the ratio over the side AB that it divided by the angle bisector, that is to say AP over BP equals to AC over BC. Okay? So we can define AP as X and AB equals to 90 degrees. So BP will be AB minus AP. So it is 90 minus 6. Okay? So actually, if we look at equation 1, we can substitute AP by X because AP equals to X, and BP by 90 minus X because BP equals to 90 minus 6. Okay? Okay, here we substituted AP by X because AP equals to X, and BP by 90 minus 6 because BP equals to 90 minus 6. BP equals to 90 minus 6 and AP equals to X. So you can see that also AC equals to 70 degrees and BC equals to 50 degrees, to 50 units. So we can substitute AC by 70 and BC by 50. Okay? So we have here x over 90 minus x equals, we will substitute AC by 70 and BC by 50. Because as you can see here, AC equals to 70 and BC equals to 50. Okay? So here x over 90 minus x equals to AC, we substituted AC by 70 and BC by 50. Okay? Now because the 70 equals to 7 times 10 and 50 equals to 5 times 10, we can write the equation again, equation 1 again. Okay, 70 equals to 7 times 10 and 50 equals to 5 times 10. So we get that x over 90 minus x equals to, instead of 70 we will write 7 times 10, and instead of 50 we will write 5 times 10. Okay, instead of 70 we wrote 7 times 10, and instead of 50 we wrote 5 times 10. So we have 10 in the numerator, and we have also 10 in the denominator. We have 10 also in the denominator. So we can cancel 10 because we have 10 in the numerator and in the denominator, so we can cancel 10. So we'll get that x over 90 minus x equals to 7 over 5. Okay, we cancel 10 in the numerator and denominator. Okay, we got 7 over 5 equals to 90 over 90 minus x. So we can multiply by 5 both sides of the equation. We will get that x over 90 minus x equals to 5x equals to 7. Okay, we multiplied both sides of the equation by 5, so 7 divided by 5 times 5 equals to 7, and x over 90 minus 6 times 5 equals to 5x over 90 minus 6. In the next step we will multiply both sides of the equation by 90 minus 6. It is allowable to multiply by 90 minus 6 because actually, as you can see in the picture, here x is smaller than 90. So 90 minus 6 will always be a positive number, and it can never be 0. For that reason, it is allowable to multiply both sides of the equation by 90 minus 6, okay? So we get that 5x equals to 7 times 90 minus 6. So we multiply both sides of the equation by x, so 7x divided by 90 minus 6 times 90 minus 6 equals to 5x divided by 90 minus 6 times 90 minus 6 equals to 5x, and 7 times 90 minus 6 equals to 7 times 90 minus 6. So we will open the brackets, okay? So we get that 5x equals to 7 times 90 equals to 630, and 7 times minus 6 is negative 7x. Okay, we open the brackets. 7 times 90 equals to 630, and 7 times negative x is equals to negative 7x. Now we will add 7x to both sides of the equation. Okay. So here 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Okay, again 5x plus 7x equals to 12x, and 730 minus 7x plus 7x equals to 630. Now we will divide by 6 both sides of the equation. Okay, we will divide by x both sides by 6 both sides of the equation. We will get that 12x divided by 6 equals to 2x equals to 630 divided by 6. Okay, 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 630 divided by 6. And 630 divided by 6 equals to 105. So 2x equals to 105, and we defined x that equals to AP, so we know that x equals to AP, so 2 times 6 equals to 2AP. Therefore, okay, we defined x equals to AP, and so 2 times 6 equals to 2 times AP, and 2 times 6 equals to 105. So we can say that two x equals to 2 times AP, and 2x equals to 2x equals to 105. So we can add here that 2x equals to 105. So we got, okay, 2x equals to 2AP, but 2x also equals to 105. So we can write here that 2x equals to 105, and that is to say 2AP equals to 105. So we got the answer. 2AP equals to 105. Okay, so that was the answer to the question. Now I will summarize the lecture. Actually, we wanted to find we wanted to find the value of 2 times AP, and first of all we connected the points P and C together, and we actually connected points P and D, and PD is the radius, and also we connected points P and E, and P is also the radius. So we actually have here two congruent triangles, because CD equals to CE, because according to the rule that if from external point of a circle V this point V is external to this circle, if from that point you drew two tangents to the circle, then those two tangents equals to each other. So VL equals to VF, and for that reason CE equals to CD, and also PE equals to PD, because PE is R and PD is also R. It is the radius of the circle, so they are equal to each other, and PC equals to himself. So actually we can say that triangle PEC is congruent to triangle PDC, or those two triangles overlap. And for that reason angle PCE equals to angle PCD. According to the rule that corresponding angles in congruent triangles are equal to each other, so we call this angle theta, and so this angle must be also theta. And actually, according to angle bisector theorem, if you have a triangle ABC and the bisector angle, it is actually PC, it divides angle ACB to two equal parts. This angle is theta and this angle is also theta. So PC is bisector angle, and this PC divides side AB in the triangle to the same ratio as the ratio of the angles sides. The ratio of the angle sides is AC over BC, and side CP also divides AB in the same ratio. So AP over AB must be equal to AC over BC, because the angle bisector divides side AB, the side that it eats, and it eats side AB. It divides this side in the same ratio of the ratio of the angles sides. The angle that is divided to two parts, the side, it has two sides, and the ratio between those two sides, that is to say AC over BC, equals to the ratio between the two sides that created by the angle bisector. That is to say AP over BP equals to AC over BC, because the angle bisector divides side AB in the same ratios as the ratio of the angle that is divided to two equal parts. So the ratio between the angle sides, that is to say AC over BC, will be the same ratio that the side AB divided. So AP over BP will be equal to AC over BC. Okay, so therefore we can write this equation: AP over BP equals to AC over BC, and we can define that AP is X and BP is 90 minus X, so we can substitute AP by X and BP by 90 minus X, and we actually know that AC equals to 70 and BC equals to 50, so we can substitute AC by 70 and BC by 50. Okay, and after we substituted those BC and AC, so we got actually this one equation with one variable. So in the end we got that 2AP equals to 105. Okay, Okay, thank you very much.